Okay, so on this example, it says a local news station says that the average wait time to get seated at a popular restaurant in the city on a Friday night is 21 minutes. But if you're a man wearing a tie, the wait time drops to 11 minutes. Hey, they honor the tie. You are not sure this is true. That's what the local news station said. So you randomly surveyed men who were wearing ties, and their wait times are shown below. Assume the distribution is normal. Well, here's the wait times. This is how long. So the first man waited 9 minutes to get a table. The next waited 12, then 8, then 11, then 12. That's pretty short. That's a lot shorter than 21 minutes. They said the wait time drops to 11, but is the 11? Yeah, there looks maybe. Yeah, it looks pretty close to 11. What can be concluded at the alpha 0.05 level significance? So is that true or not? So let's go to the notes. So here we are, Unit 3 notes, page 2. So first off, is it a percentage question? Is it a percentage question or a mean average? It's an average, right? Because we're talking about, it says it right here. It says the average wait time. Okay, it's all about average. So this one's an average question, not percentage. Then you're going to use t-test for population mean right there. T-test for population mean. So, and that's the first thing we did, t-test for population mean. Okay, so let's come on down to the HO. The HO is the null hypothesis. Null means zero, that little zero there. Null means like your check is null and void, zero. Okay, HO. What do we do for HO? If you come to the notes, notice HO is always equal right here. HO is always equal, whereas H1 is greater, less, or not equal. By the way, they're both P or mu. Which one is it? Well, not P. This is not a percentage question. This is mu. This is an average question. It's the Greek M. It looks like a U, but it stands for mu, the Greek M for mean, average. So anyway, again, HO is always equal and H1 is greater, less, or not equal. So let's go back. HO is going to be mu equal always. HO is always equal. And this one's going to be mu, and it's either going to be greater, less, or not equal. How do we know which one? Well, we got to look for some words. Is there something that says greater, less, or not equal? It says no, it never does. It just says, the average wait time is 21 minutes, but if your man wearing a tie drops to 11, you're not sure. Like, it doesn't say you think this is bigger or lower, or it doesn't say. So that means it's going to be not equal. Oops. Okay, little technical issues. There we go. So not equal. Not equal because why? It never says greater or less. It never says greater or less. Never says it. So that means it's not equal. Not equal to what? Not equal to 11. Don't be confused by the 21, right? The 21 was just the average when you're not wearing a tie. But if you are wearing a tie, the wait time drops to 11. And so that's what they're saying, 11. Now this one's also going to be 11. And these two are always the same number. Always the same number. They're saying opposite messages, right? H1 and HO. So HO is saying the average is equal to 11. If you're wearing a tie, the average wait time is equal to 11. H1 saying, no, it's not equal to 11. Not equal. So we're saying, is it really 11 or is it not equal to 11? That's what we're testing. All right, how do we test it? Well, we got to go to the calculator. Well, first, let's find out which calculator. If we come down here to the notes again, is this a percentage question? No, it's an average question. Is there no data given or data given? Well, that was data. Clearly, there's a bunch of data right there, right? Bunch of numbers, right? This is the first man wearing a tie, got in the restaurant in 9 minutes. Next was 12, then 8, then 11. Those are the actual men and the times it took them to get into the restaurant when they're wearing a tie. So what do you do with that data? Well, it comes on down here again. So we're doing the mean average data given. Go to the online calculator hypothesis test for a mean with data. Hypothesis test for a mean with data. So I'm going there. Come on up here. Hypothesis test for mean with data. So we do indeed have data. And so what does that mean? Well, if you come on down here, It says enter the data at the top, copy and paste from the problem, put commas between the numbers. Mu zero is the number from H0, radio button, choose whichever matches H1. Okay, let's go do it. So we're going to go grab that data. So you got to go to the right calculator first off. So hypothesis test for mean with data, it's number 15. See it there, hypothesis test for mean with data, number 15. And we got that. And then there's the data at the top. Put yourself in that cursor. Now I'm going to go to the problem and copy and paste. Here we are. There we are. So I've already highlighted and copied that data. So you need to highlight it, hold down Control or Command and hit C for copy. And then now we'll go back to the problem and we'll put our cursor in the data box, hold down Control or Command again and hit V, like value for paste. And it will paste it. And there it is. They've already got the commas between them. If they didn't have the commas, we have to put them between there. The spacing is fine. Just leave it. Now, I'm not going to fill in the sigma, but the mu zero, let's go find that. So, right up here. So we've got to get the mu zero. Now, what's that? That's the number from H0. So you just grab the number right there. It's 11. That's what the mu zero always means. It reminds you to go to the H0 and grab the number right there. And then there's the radio button, you know, greater, less, or not equal. And that's always from H1. It's the symbol from H1, not equal. So that's going to be not equal. So there's the radio button we're going to do there. So 11 and not equal. Let's go back. So the mu zero is 11. And then I see the radio button. I'm going to choose the one that says not equal. Again, don't worry about that sigma over on the left. Just leave it be. Hit calculate. Calculate. There it is. The T is negative 1.37. P is 0.19. There it is. Sure enough, that's right. T is negative 1.37. P is 0.19. We got the right answers from the online calculator. Now, so you put those in here and here. Now it's all about what does that mean? What in the world does that mean? So we got a p-value of 0.1931 right there, p-value. And what was the alpha level? They told us that the alpha level right here, alpha is 0.05. I'll just say 0.05. I don't need that extra zero. Okay, so how do those compare? Well, obviously greater. 19 is bigger than 5, clearly. So our p-value is not low, it's greater. P is greater, it's not low. It's greater. 19 is greater than 05. Okay, what does that mean? Come on down. So do we have P less or P greater? We have this one, P greater, not that one. What do you do when P is greater? When the P is not low, the null must not go. It means when the p-value is not low, it's greater, the null must not go away. That is, fail to reject the null. Keep HO, weak evidence. So we go back. Let's do that. So we're going to say, this means, so the saying that every stats student needs to know to answer hypothesis test questions is when P is low, the null, which is HO, must go. Now, what do we mean by that stuff? Well, we mean, oh, and in our case, the P is not low, it's greater. So then you got to add a not here and a not here, and the go means go away. So our saying becomes when the P is not low, because our P is not low, it's greater, right? That 19 is greater. When the P is not low, the null must not go away. So that means we're going to fail to reject the null. It's not going away. So we're, oops, sorry about that. We're keeping the null. So right here, fail to reject the null. And I'm getting all that from right here. The p-value is greater, which means what? The null must not go away. When the p-value is not low, the null must not go away. That is, fail to reject the null. Keep the null, weak evidence. So let's go back. Keep the null, weak evidence. Right here, weak evidence. Okay, and now, what does that mean in the end? So our conclusion is that for men who wear a tie, the average wait time to get seated is equal to 11 minutes? Is that true? How'd we come up with that? Well, because it's all about which attorney we believe. Remember the two attorneys that were arguing? HO said the average was equal to 11. H1 said, no, it's not equal to 11. Well, who did we believe? Who did we have confidence in? We keep HO, right? So we go back to HO. This is HO, and this is the one we keep. What does that say? It's equal. Mu is equal to 11. That's why we said equal to 11. So when all is said and done, we concluded that the average is really equal to 11. These numbers came out pretty close to 11. We think it's equal to 11. In other words, you might say, so why did we say fail to reject? Weak evidence. Well, there was weak evidence that it was different. There wasn't any strong evidence that it was different than 11, right? So we stayed with HO, which said it's equal to 11, equal to 11. That's our conclusion. And there we go.